Okay, let's just start with the joins. This is the most important and basic, fundamental, and most critical part of SQL, where you would like to join the two different data sets. Okay. So, Mayank, can you tell me about the different joins? I mean, you are aware of?
Yeah. So inner join, left join, right join, full outer join. Some self join sometime also we do. So inner join basically it will be the intersection of two tables basically. And left join, left table will be having all the row and will pick whatever matching from table B, and vice versa of yeah. So right join is basically opposite of left join. Full outer join is basically it's kind of it will take all the things like all the row from table A and table B.
Okay, perfect. That is correct. Pratiksha, are you aware of joins?
Yes.
Okay, awesome. So I think you have not heard of this Cartesian join, right?
Yeah.
So this Cartesian join is also called cross join. And what it does is, let's say you have 10 rows in the first table and you have 10 rows in the second table. What it will do is it will join each row of first table with each row of the second table. So you will get results at something like 10 cross 10. That is what we call a cross join or a Cartesian join, where each and every row of the first table is joined by each and every row of the second table. Okay.
How is different from this full join?
So full join would be like, think of it as there is 10 rows in the first and there is 10 rows in the second, correct?
Then 20 it will be, right?
Then 20 it will be, yes. Let's say there is, even if there is no match, then maximum what we will have for first table, we will have, I mean, these are two different tables. They are not joined all together, but we are trying to join on a key and there is no match in the keys on which we are trying to join. Okay. Then 10 rows of the first table will be there, 10 rows of the second table will be there, and then total 20 rows will be there. But in case of Cartesian join, the join should work, and it works in such a way that each row of the first table gets joined with each row of the second table. So result set ends up becoming 10 cross 10 or n cross n. N where m cross n, where m being the number of rows in the first table and n being the number of rows in the second table.
Okay.
Okay. So this Cartesian join is also called cross join. So I would like you to go through this DSI SQL join thing. So this is a very actually good visualization. So as you said, let's start with what is a join. A join is basically a SQL statement to merge together certain rows from two or more different tables. I mean, as you said, there is a self join also, in which case we basically attempt to join a table with itself on different column. But yeah, the general nuance is we are trying to join two different data set with each other on a basis of some certain attribute, key attribute. It could be a primary key, foreign key concept, or it can be a composite key as well. Now, this joining is done based upon one or more columns that are shared by each table. So the thing I mentioned, it can be a primary key or foreign key, or it can be a composite key. Now, what we don't want is we don't want the data of all of our data within one single table. That is not an ideal approach, and that's why we have multiple different table, and then we join them and get the data into one single view as per our requirement, as and when we require. Correct. And this is the concept what we have read about is called normalization, and which would remove the data redundancy and increase the performance and optimize our processing power. Now, the different types of join that we have is, as Mayan just told, left join, where we have all the table which is at left, all the data from the table which is at left, and whatever the common data we have from the right one. Let's say if there is some data set in the left table, which for which there is no corresponding key exist in the right table, then data from that right table won't be there in the joining condition in case of left join. So all the data from the left table will be there, but only that data from the right table will be there for which we have joining condition. Now think of this scenario as a vice versa. Like now the data from all the data from the right table would be there, but data from the left table only that data will be there where we have the joining condition met. So that would be a right join. So just in easier terms to remember, what you can do is left join means all the data from left table and matching data from the right table. In case of right join, all the data from the right table and matching data from the left table. In case of inner join, only the common data would be there, intersection. I mean, the data that is there in both the tables, only that data would be displayed. So if there is, let's say, XYZ data in left and ABC data in right, and now this XYZ and ABC are not present in the respective tables as well. So XYZ is only in left, ABC is only in right. Then both of these data points will be excluded, and only the common data point like MMM, AAA, whatever the common data point that would be there will be showcased as an inner join. And then let's say we have a full join means all the data from the left, all the data from the right, all the data from all the tables. Like in case if there are 2 or more tables involved, then all the data from all the tables. And cross join is what we were talking about as a Cartesian product or a cross product. Now for better understanding, let's consider these two tables where basically both table contains an ID column, table A and table B. Now, can any one of you tell me what if I will do a left join with table A? What would be the result?
Only row 1.
And what if I do a right join?
Again 1 only. First row.
Isn't that wrong, man? So in case of left join, 1 and 2 will be there, and that's it. And in case of right join, 1, 3, and 4 will be there.
Yeah, but from table A only first row will be coming.
In case of left join,
yeah, left join.
Why only one row will be coming? All the rows from the left table will be coming, right?
No. In while doing the right join, we'll get all the row 1, 3, 4 from table B, but
yes.
But from table A, we'll only get the row 1.
Perfect. But in case of left join, how it would be?
It will be 1 or 2. Then
but only correct. Perfect. That's correct. And in case of inner join?
Only 1. First right.
Perfect. So this is a good visualization that he has showcased. Let's say he has hair and he has a beard, but now let's say in one case he's doing a left join with his hair, and in another case he's doing a right join with his beard. So that's how he's trying to showcase. Now the inner join that we were talking about is 1, which was correctly mentioned by Mayank. So this is a Venn diagram which we have used in the previous slides also. So this is the visualization that I was talking about. Inner join, no hair data from the left table was matched in the right table. Only face data was found in both the tables. No beard data from the right table was matched in the left table. Left join, as correctly mentioned by Mayank, 1 and 2, and only one data would be there from table B. Correct? And let's say then there is right join. What Mayank said, 1, 3, 4, but only one data from the A, table A. That is also correct. And in case of full join, we have all the data from all the tables. So it is 1, 2, 1, 1, 3, 4. So it is 1, 2, 3, 4. So like full join in this particular case is trying to showcase that he has hair and he has beard and he has everything. And this is how your cross join would look like. So if you will see here, 1 is getting matched with all the 3 rows. 1, 1, 3, 4. 2, 1, 3, 4. This is how a cross join would look like. Does that give a clear picture now? How a cross join would work?
Yeah.
Okay.
When
So
we use this Cartesian join or cross join and self join.
okay, so let me give you an example which is asked in the, I mean, interviews also very often. And let's start with the self join first. So let's say there is a table where data is mentioned in such a way that you have an employee ID and corresponding to that you have a manager ID. Correct?
Okay.
Now, manager is also an employee.
Hmm.
So in under manager column, for each employee there is a respective manager ID, which is nothing but a manager's employee ID. And then in the table, manager exists as an employee as well. Correct?
Yeah.
So what you would do is you would do a self join of that table with itself, but on a employee ID and a manager ID column in order to get the manager's name. Does that make sense?
Not 100%. Yeah.
Not 100% we are getting. Let me show you. Uh, what was it? Alter table add column, was it right? It was something else. So it is in case it is the keyword column. What if I do alter? Alter table alter column failed because column ID does not exist. That is true. I'm trying to add a column. What would be wrong? Okay, I'm sorry, I mismatched with the syntax. So it does not require a column keyword. It just says add and this. Yes, let's see. But if I do a refresh now, okay, and now I'll do a select star from this table. And now we have 0, 2, 3, 4, 5, 6, 7, and 34. So let me do this thing. Update. Yeah. Set MID equals to 34, let's say. Let's take this one. Where EID is equals to this. Okay. And now where EID is equal to 6, let's have let's have 7 here. Sure. Now let me show you. So how we can read this, and now I'll show you the example of self-join. So Meg, you are able to see here, right? EID means employee ID, MID means manager ID. So now what we are able to see is that Dinesh Rawat and Ikansh Gupta, right? For these two candidates, we have a manager ID that is 34 and 7. So what we are saying is that Dinesh Rawat's manager is that with the person with employee ID 34, his name is Bob Singh. Correct?
Okay, got it. Yeah.
And now you're saying that Ikansh Gupta's manager is this guy with employee ID 7. That is Anul. Now you ask me that can you give me EID, name, and his M name, manager's name. Correct? Now first what I need to do is I'll do a self join with him table where I'll be doing on A.EID equals to B.MID. Something like this will do. And now what we will do is A.employee ID, A.name, and then we will have B.name. Make sense?
Yeah.
Now let's see what do we get. Correct?
Yeah.
For Dinesh Rawat, Bob Singh, Ikansh Gupta, Anul. So this is how the self-join works. So this is a typical example for a self-join where a company, where in interviews, we have been asked that we have given an employee table, whereas where that employee exists as an employee as well, but in the another column called manager ID, that employee ID exists as a manager. So now you need to do in such cases, we need to do a self-join and showcase the manager's name corresponding to the employee's name. Okay.
Yeah.
Another thing that you were asking me was Cartesian join, use case of Cartesian join. Use case of Cartesian join. Okay, I'm not going to show you, but I'll explain you the way you can do it. So let's say you have a smaller product table. let's say you have 10 products. Okay. Now, what you want to do is you want to map those 10 products with each employee so that they can further sell them. Correct. So
Yeah.
let's say you are a business development organization where what you do is, or you are a sales organization where you do the retail sales, and now you would like to showcase the inventory of 10 products corresponding to your each of the employees, so that what you can do is you can showcase which employee has sold out of these 10 products how many units. Correct. So in such a case, what you will do is you will do a cross join of each employee to the products table, where each of the employee will be showcased against the, I mean, each product will be showcased against each of the employee, and then further you can update the inventory as how many products he has sold. So in such situation, you can do a cross join or a Cartesian join as well. Okay. I mean, use case does exist. That's that's one of the reason. I mean, I know that there are very rare use cases of Cartesian join, but yeah, they are there.
Okay.
Okay. So I think we have already talked about inner join, but I've not talked about is uh, the how they are referred as in another way. If someone tells you like, can you do an equi join? It is as same as an inner join. Okay. Another thing, the syntax to do an inner join is you can write select, you can choose the column list from table 1. Then you need to do you need to write a keyword called inner. By default, if you do not write inner and you just write join, it is an inner join. Okay. So right now, when I was mentioning join here, if you remember, right, this join when I did. So I'll show you the result set was this, right? Now, even if I mention the keyword inner, right, the result set is going to remain same. So by default in SQL Server Management Studio or T-SQL or SSMS, inner join and join are same. So you can write the keyword inner or you can choose not to, but it will do the same thing. What you need to do is you need to write from table 1, inner join table 2 on table condition, like on table 1 dot column name on which you would like to join, and or table 2 dot column name on which you have to join. Other way you can do it, the way I've done is you can alias the table name. I've aliased the table name as A. Another thing I wanted to tell you was this is also same as A and as B. If I will write it this way, it will still give the same result. If I do not write as, it will still give me the same result. So after table names and you give a space and then you whatever you write is the alias of that table or the column itself. I mean, in this particular case, if I do not write as, right, it will give me an error. Sorry, it will not, I guess. Yes. So if without space I write, it will not give me an error. But the problem here is, what if I would like to write PR space num? Now it gives me an error. So without space you need to give, and you can choose to write or not write as. But yeah, what we are trying to mention here is that you can do aliasing, and then you can use those aliasing to further imply or mention specifically that particular attribute of a table or table name itself. In this particular case, what I'm doing is either I need to write dvo.imp.eid and dvo.imp.mid. Instead, what I did was I choose to alias the table name with a shorter name, and then I referred that shorter name to refer the table itself, a.eid and b.mid. What we are trying to write here, like either you can write the whole table name, or you can just alias this table name with a smaller name and then use that alias dot attribute name, and then the second table name alias dot attribute name. I hope this is clear. Any doubt? This is basically your SQL querying style. It is totally your choice. Would you like to be explicit or not, or implicit or not? So whichever way you like, you can use that. Either you can choose to write inner and you can choose to write the full name of the table, or you can just choose not to write inner and just write join and provide alias to a table name and then use that alias further. Any questions? No, I guess. Let's move ahead with the left join. In case of left join, we need to mention the keyword left specifically. And when we say left, what you need to remember is to this left join where you have written whichever table is on the left side of it, all the records from that table will be showcased. Always remember that. Any doubts?
Yeah.
Okay, awesome. I don't think so. Any questions? Same goes for right. Now when you have, I mean, for right join, we need to use the right keyword. And now whichever table is to the right of this right join, all the records from that table will be showcased and related records from the left table will be showcased. Not all from right to this join will be showcased and relevant or related records from the left table. Then in case of full join, we mentioned the full keyword. Either you can write full outer join or full join. It will yield the same result. These are the Venn diagrams. Cartesian join or cross join. So, I mean, the keyword that we use is called cross. And you can call it as a cross join or a Cartesian join as well. We have already understood what it does, how it does. Okay. And we have talked about the self join. In case it looks like there is another way to write a self join also. So in this way, what you can do is you can, instead of writing a keyword self join, you can mention from table 1A, table 1B, aliasing has been done. So same table name has been first alias with A and then second as B, where A dot common field is this. So in this particular case, what we're trying to do is with the help of where clause, we are trying to join these. So let me showcase you this particular thing with that way. Same result, right? What you can do is, this is another way to write a self join. So either you can choose this or the one which I chose earlier. So the reason I chose that one is because most of the time we will be writing join in the previous way only. We rarely write joins in this particular way using where clause and like providing name such as this. In PostgreSDB, we do this a lot of time, but in T-SQL, we don't do this that much. Hence, I prefer over this way, that way. But that's totally your choice. Whichever way you would like to write, both the ways are correct. So this is what they are trying to explain. Annual Nikunjan, the manager hierarchy that I was trying to explain.